this lesson, we're going to introduce sigma notation.
Okay, hi everybody. So what we want to do with this lesson here is just introduce sigma notation, okay, which is our summation notation. Now, for a lot of you that I would have worked with, it has been a little while since you would have dealt with sequences and series. So we're just going to quickly review a little bit here before we get into just a really brief introduction to the use of sigma notation here. So just remember that a series is the sum of a sequence, okay? The sum of a sequence, and a sequence is just a pattern of numbers. Okay, that doesn't even have to be a pattern of numbers. You can have other sequences there, but I mean, typically what we're looking at here is a pattern of numbers separated by commas. It follows a very specific rule. Okay, so it's typically simple to express the terms of a sequence with a function where n is the variable and n is an element of the naturals, and it's basically to give us it's an ordinal number. Okay, so it's telling us the order that they come in. So for example, in this arithmetic sequence you got 4, 7, 10, 13. So right here, this first one here, n is equal to 1, 7, n is equal to 2, 10, n is equal to 3, 13, n is equal to 4. So it's just our variable here, n, is just a way of counting the terms in the sequence. And then we find a way to associate the value of the n here with the value of the sequence if we can. And then actually in this case we can, because we start off with 4. And if you think back to our general arithmetic sequence, okay, the general term in an arithmetic sequence here was Tn is going to equal to the first term plus n minus 1 times our common difference, d. And I know there's slightly different notations out there that people use, but that's generally around here that's fairly commonly accepted one. And then we can simplify this down here, this one in particular, to 3n plus 1, okay, to get all the terms of the sequence. Now, in addition, we can specify a specific part of that sequence by just restricting the domain on the variable n. So we can say that we're dealing with a sequence that's 3n plus 1, but we're going to leave n to be values between 1 and 6, including the 1 and the 6 here. And that just gives us these values right here. So we've just got the general rule for it, and then we've got a restriction on the domain. Now, it would be convenient if we had something sort of similar to that when we're dealing with addition, okay? So we've got now with a series, as soon as we put addition signs in between, then we're starting to talk about a series, and we're adding those pieces together. It would be nice if we could have some sort of way of doing basically this on the sequence, still implying the addition here, because bear in mind that we're still dealing with the terms in the sequence. This 3n plus 1 is still important. It's still a significant part of the way this pattern of numbers is developed. We just want to communicate that we're adding things together, and then maybe we want to have the ability to do what we did up here and just restrict it to a certain group of those terms there. And the fact is, we can, and what we do here is we use the Greek letter sigma to do it. And so here's what that would look like. So if we want to restrict our sum to just the terms in the sequence from 4 up to 19 here, okay, what we do here is we use the Greek letter sigma here, and it represents the sum. So let's just ignore the other little pieces here, the top and bottom here. What this is saying here is I want you to add up the terms of this sequence. Okay, that's all this means. That's all this means. This means sum the terms of the sequence. Okay, that's it. And I love the fact that if you look at popular culture here and on like TV and movies, they're trying to really establish that when someone is really smart here, you'll often see the summation symbol here. And because it gets used in some pretty interesting ways here, but it really just means add, okay? And then what we do here is we add and we let n equal this lower limit. We start here, and so we plug in the 1, figure out what this is equal to, then we plug in the 2, figure out what it's equal to, add them together, plug in the 3, figure out what it's equal to, add them together, and we do that up until the point where n is equal to 6, and then that's when we stop. Okay? So this right here, behind the sigma, the symbol here, this is the general term of the sequence. This tells us to add the terms in the sequence, and then we do that by starting with the n value being here, and then it goes sequentially all the way up to 6, or to the upper value right here. Okay? So anyway, probably the best way to get used to this is just to see it in action, to do just a couple of simple experiments with it, or questions with it. Okay, so for our first example here, using the sigma notation, we're just being asked to write out the following sequences in expanded form. So we're going to take these two runs here, we're going to expand them out, and then we're going to find the sum. It also asks how many terms there are in the sequence. Okay, so let's just take a quick look at this one here. So we've got 10 plus n minus 1 times 13. We're going to let n go from 1 to 20 here. So we start off with n equaling 1. Well, 1 minus 1, okay, is going to be 0 times 13 is going to be 0, plus 10 is going to be 10. For our next term here, I'm going to let 1 equal 2, so this will be 2 minus 1 is going to be 1 times 13, okay, is going to equal 13, plus 10 is going to equal 23. And you can see here that basically all I'm doing here is adding 13 every step along the way. So the next one's going to be 36, it's going to be 49, going to be so on and so forth. And actually, I mean, we could do all of that, but we'll just give you the last few terms because I've got those worked out here. We would do that up until the point where we get, let's say, n is equal to 18 would be 231, n is equal to 19 is going to be 244, and then finally we're going to end at 257. Okay, so we could figure out all the terms in that sequence, and I could, but I mean there's a bunch of them there. Now we want to figure out what the sum of the terms are in the sequence. Well, I could enter that all into my calculator. I mean, I could get all the in-between parts here and do that. But because this is just an arithmetic sequence, it's just going up by 13, I know what the sum of an arithmetic series is. Okay, so I know that the sum of, well, you know what, first of all, I got to figure out how many terms there are. Well, I mean, I took a little bit of a cheat here. Okay, I can't just count up the number of terms that I used here because I did a little bit of a cheat. I skipped over because I knew it was going to be fairly repetitive. So let me take a quick look at my limits here and see if I can figure this out here. So I started where n is equal to 1 and I ended when n is equal to 20. Okay, so let's just think about that. I mean, that's basically me just counting the terms. This is the first term, second term, third term, up to the 20th term. Well, because I started at term number 1, I'm going to have 20 terms. So I'm going to add up the first 20 terms of this particular sequence here. Okay? So now, whoops, this is going to be 20 over 2, and then it's going to be 2 times the first term, 10, plus 20 minus 1 multiplied by my common difference here, which in this case is going to be 13. Okay, so now I'm just going to go to my calculator and plug that in. And I get 2,670. Okay, there's the sum of that particular sequence here. And I've got 20 terms here. Now, just so that you have an idea of how this works here, let's say that this didn't start at 1. Let's say this started at a different number. Okay, then normally what we would do here is to get the number of terms. Okay, we are going to take, it's going to be the upper limit minus the lower limit. Now, the thing is, that doesn't quite get you the right answer here. Right now, if you were to go upper limit minus the lower limit, just figure out the difference between them. 20 minus 1 is going to be 19. Well, that's not how many terms I have. Okay, what I got to do is I got to add that first term. When you go 20 minus 1, basically you've eliminated that original term here, that starting point, but I have to include the starting point. So typically what you got to do here is upper limit minus the lower limit plus 1. Okay, for this question we're doing the same thing as the previous one. We're going to expand this, and then what we're going to do is determine the sum and add together the, figure out the number of terms there are. So once again, I'm going to start with 1 here. So this is going to be 3 times 2 to the 1. Okay, well, 2 to the 1 is just 2 times 3 is going to be 6. Plus, now I just increase this by 1. 3 times 2 squared. Well, 2 squared is 4 times 3 is going to get me 12. Plus 3 times 2 cubed. Well, 2 cubed is going to be 8. 3 times is going to be 24. Now, notice what's happening here. Every step along the way, all I'm doing is multiplying by 2. So this is where n is equal to 1, 2, okay, 1, 2, 3. Now my next one's going to be 48, 96, 192, and actually in this case right here, I am going to go through and do all 8 terms because there's only 8 terms. It's not a big deal. So 1, 2, 3, 4, 5, 6. Got to do 2 more here. So multiply by 2 is going to be 384. Multiply by 2 would be 768. Okay, so there are 8 terms. So n is equal to 1, 2, 3, 4, 5, 6, 7, 8, and then I've just assigned natural numbers to each one of those. So clearly I've got 8 terms here. So now the sum of a geometric sequence, because that's what this is. I'm multiplying by 2 in every step along the way. You got to think back to the formula that we've got for that, and you would have seen that in the previous course here. We are going to sum together the first 8 terms. That is going to be the first term, which in this case is going to be 6, multiplied by my common ratio, which in this case is 2, to the 8, minus 1 all over the common ratio minus 1. And when I plug that into my calculator, I am going to get 1,530. Okay, so these we're using to do the actual summation. We're using formulas that you were aware of before. Remember that the sigma notation here, it's not doing the adding for you. It's just telling you that that's what you want to do, and it's giving you the restrictions on the variable. Okay, it's just a form of notation telling you what you'd have to do. Now, to do it, you're probably going to go back and use some other tools you would have learned in a previous course. And remember here that, and I didn't write this down here, there are 8 terms here. Okay, probably should have wrote that in the previous one. And the one that we just did up here, remember that there were 20 terms. Yeah. Okay, anyway, let's keep going. Okay, now for our next question here, we've already basically dealt with this. It says, what's the relationship between the number of terms in the series and the upper and lower limits in sigma notation? Okay, so I've already discussed that with you. We know that it's going to be the upper limit minus the lower limit, okay, plus 1. And this is going to be the number of terms here, but just so that you can kind of catch what I'm saying here, let's throw this down here. Let's say that we're going to start with I equal to, I don't know, let's say 4, and we're going to go up to 10 here, and let's just say it's going to be I squared. Okay, so the way we do this here is we're going to plug that 4 in, because we start at this lower limit. It'll be 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared. Okay, well, how many terms was that? 1, 2, 3, 4, 5, 6, 7. 7 terms. Now, if you just go 10 minus 4, that's going to be 6. It's going to be 1 more than that, because think about it like that. 10 minus 4, okay, if I, the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, if I went 10 minus 4, then what I would do is I would cover up the numbers 1, 2, 3, up to 4 here, and then what you're left with are 1, 2, 3, 4, 5, 6 numbers. But here, we're starting at 4. So I'm going to take the difference and include that one term that I'm starting with. So that's why the relationship is upper limit minus lower limit plus 1. Okay, so now in this question here, we're going to write the following expressions here in sigma notation. So let's zoom in a little bit. Okay, so take a look at what I'm doing here. Every step along the way, it looks like I'm multiplying by a half. So I'm going to add together, and this is going to be, well, what have we got? We're going to start with 3. And I am going to multiply by 1/2 here. Now, I'm going to use n as my variable, and I'm going to let n start at 1. Then the reason I like letting n start at 1, because then when I just count the number of terms I've got here, 1, 2, 3, 4, 5, 6, up here, my upper limit here, that can just be 6, and then I'm good. So now I got to make sure that this matches with what I'm seeing here. Now, when n is equal to 1, I want that multiplication factor there, that 1/2, to disappear. So to do that, I'm going to have up here my exponent n minus 1. So let's just double check that, because I know when n is equal to 1, that will disappear and I'm left with 3. But if I put n equal to 2, 2 minus 1 is 1. Yeah, and I'm going to get the 3/2. And so that's what I'm looking for. Okay, for this question right here, I've got, okay, what have I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 terms. Now, this looks to me like not geometric sequence, it's an arithmetic sequence, because I'm losing 3 every step along the way here. Okay, so my term, if I just do my term here, Tn is going to equal 25 plus n minus 1 multiplied by negative 3. So that, if this was just a sequence, this would be the general term of the sequence.
I'm going to simplify that a little bit. It's going to be 25 minus 3n plus 3, or 28 minus 3n. So that's the general term of my arithmetic sequence. That's what I'm going to put inside my sigma notation here. So my sigma notation is going to be 28 minus 3n. And I'm going to let n go from 1. And we already counted out here, we already know that there's 9 terms, so I'm going to let this go from 1 to 9 here. And if I plug that in, let's just double check that. If I plug 1 in, it's going to be 28 minus 3, there's my 25. If I plug 2 in, 28 minus 6, there's the 22. Yeah, that's the expression that I'm looking for. Okay, this question here, and this is a little short. I mean, I can tell right now I've only got 4 terms. And what it seemed to be doing here is I'm multiplying by -5 here. So this is going to be the sum. I'm going to let n once again start at 1, and I'm going to go up to 4 because I can see there's only 4 terms. This is going to be 3 multiplied by, looks like -5. Now in the first term I want that -5 to go away, so for my first term I need the exponent to be equal to 0. So I'm going to make that n minus 1. And now just to double check here, if I do n is equal to 2, that's going to be 3 times -5, -15. N is equal to 3, that's going to be n squared 25, and there's my 75. So yeah, that's the way that's supposed to work there. So there you go. Just a very, very brief introduction to sigma notation so that you get a sense of how it works.